So this Proctor Compaction Test, it has got a mold for you to fill the soil, and then you compact them using this hammer. But later on, when you are in USM, you can drop by the lab and look at this instrument. So that is the hammer that is used to compact the soil. Right? Of course, when we do some tests, it should be according to certain standard. Right? In this case, there are standards that we need to follow. You cannot just go and compact that as you like. It has to be following certain procedures. In this case, I'm talking about 3 procedures that we usually use here in the lab. But of course, you may have your own procedure in your country or in different countries, right? So in Malaysia, we usually use British Standard 1377-4 or European Code 7-2 or American Society of Testing Material Code D698-1557 or 7382 for this Proctor Compaction Test. I know you have a standard in China, in Jordan, in Australia, in Japan, that you have your own standard, which is not very much different from the standard that we use here. But also, I'm sure you use similar equipment. It's just that probably a little bit different in terms of preparation, things like that. But I'm sure you have adopted certain standard that you use in your country. Now, if you look at this illustration, even the Proctor Compaction Test, there are 2 types of Proctor test. One is a standard Proctor, second is a modified Proctor. The standard Proctor, we use a lighter hammer, and the modified Proctor will use a heavier hammer. You can see here 2.5 and 4.5 kilo hammer to compact the soil inside this mold, right? This mold. And the way we prepare the sample, in this case 3 layers, in this case 5 layers, right? 3 layers and 5 layers of soil that we prepare to do the Proctor test. So I remember the Proctor test is used to identify what would be the maximum dry density. Remember just now we try to achieve a maximum dry density based on certain amount of water. What do you call it? Added to the soil. So for Proctor Compaction Test, the concept is very easy. This is a textbook material of definitely you can check this out from many textbooks in the library or even in the internet, the Proctor Compaction Test. But let us just go through quickly the concept of this test. The concept of this test is very simple. Soil, you have the soil, you mix with different amount of water, soil and water. And then we compact them at least 5 times to get, why 5 times? Remember just now the curve that I show you? So because we need to plot the curve to find where is the maximum density that we can achieve. So remember as you start adding water into the soil, you will get different strength. You will get different compaction strength. But as you add more water, the strength will start diminishing. It start reducing. So we want to plot this curve. Once we have plot this curve, we know where is the maximum density that we can achieve, and what is the amount of water that gives that maximum density. We need this information for us to use later on site. How much water for you to spray onto the soil before you use roller to compact that. So basically that is why. Another reason is for us to compare the result, the compaction result on site and the compaction result in the lab. Okay. So in this case, we will calculate what we call the unit weight. We will find what is the dry unit weight. So what we finally plot to get the maximum density is the maximum dry density, right? Dry density. So let us just look at the second item here, which is unit weight, which is gamma here equals to the weight of the soil itself divided by the volume of the mole, right? So remember just now you compact the soil into the mole. So definitely you have the volume of the mole and you know the weight of the soil that has been compacted into the mole. So unit weight in this case is the weight of the soil, kilogram, divided by the volume in meter cube. So weight of compacted soil in the mole divided by the volume of the mole itself. Then you will get what we call the unit weight. And moisture content, how do we get the moisture content, which is M% or W%, depending on the code that you are using. Sometimes they use small w, sometimes they use small m %. That is basically the moisture or water content. Where do we get this moisture content? Remember, we have just compacted the soil into the mole just now. So we'll take a small sample and then put in a small tray and weigh them. We get certain grams and then we put in oven. After 24 hours, we bring out. It is dry, no more moisture. Then we weigh them again. So the difference will give us what is the moisture content. So as simple as that. So that's moisture content. Now, once we have got the moisture content and also we have got the wet or what they call it, in this case we call it bulk density or bulk unit weight or wet unit weight here, then we can go to the next activity, which is we need to calculate the dry density, right? Why we need to calculate the dry density? That is because we want to plot them like this. Remember just now we have at least 5 samples. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8 more samples. So in this case, I have 8 samples, 8 compaction mole. So with different amount of moisture or water inside. So how do I, because to plot this chart, I need the dry unit weight instead of the just unit weight just now. I need a dry one. For me to know the dry unit weight, I need to do some calculation, which is the gamma dry or the dry unit weight, which is equals to the gamma or the unit weight just now from the previous formula. Unit weight here, which is equals to, remember this equals to, remember this one equals to weight divided by volume, right, of the mole. So the dry unit weight that I need for my chart here is from this formula, which is equal to the wet unit weight divided by 1 plus this one. Remember from the oven just now that you have got the percentage of water in the soil divided by 100, and then we will get this gamma dry, and then this is the gamma dry. Then we will plot the gamma dry here versus the moisture content. So you have one here, so that's the curve. Okay. So when I have got this curve, then now it is clearly shown, clearly it is clear to me that where is the optimum moisture and where is the maximum density, right? Or unit weight. So now I've got this curve. It will be produced in report format and so on. Usually, the lab will produce report. For example, my lab here in USM in HBP is called HBPTU, HBP Testing Unit. We are an ISO 17025 ISO standard lab. We are accredited lab. Now we have we are able to identify where is the maximum density, where is the optimum moisture content. Then we are already in step 2. Remember just now the step 2 in the sequence of engineered field. We have got this reference point, a reference standard that we will compare with the compaction of soil that we are going to do on site later. Just a little bit more information. Other than this maximum and density and also optimum moisture content, if you are accredited lab like us, you are expected also to provide information on what we call zero air void ratio curve, which is here, and also saturation, 80% saturation curve, which is usually about there, right? So we need to be able to draw this chart. This is the calculation. I will skip this calculation, right? So what do we do with the result just now? This is because on site, you are expected to achieve the same. When you do compaction on site, you are expected to achieve at least, in this case, if you are talking about building platform or road work, 90% of what you have achieved in the lab. Let's say your lab gives you 20 Newton per meter cube, 20 kilonewton per meter cube, right, of unit weight, right? So 90% meaning, so on site, your compaction has to achieve at least 18. Otherwise, you have to recompact, more compact, or you have to add more water, or even you need to let the soil to dry because of it's too wet before you compact again. But you must achieve at least 90% of the dry density that you have got in the lab. So typical requirement, I say, will be 90 to 95% from the maximum dry density that you get in the lab. The specification normally in the term of relative compaction, meaning you compare between your dry density in the lab divided dry density on site divided by maximum density that you have got in the lab just now I mentioned, and of course this is the percent that you have. But in some situation you have to achieve 100 or more. You have to achieve the density of 100%, meaning you have to achieve whatever you have achieved in the lab or even more. You may be asking, is it possible to achieve higher density than what we have achieved in the lab? If you use a standard rolling equipment and then you use a heavier rolling equipment, it definitely gives you more than 100%. So that is how sometimes on site you will get your compaction density higher than 100%, which is okay.